Hello everyone, welcome to Biotechnotebook. In this video, we are going to see how to calculate the log mean temperature difference LMTD is. Okay. So the problem is fermentation medium is cooled from 121 degrees centigrade to 30 degrees centigrade in a double pipe heat exchanger. This picture shows a diagram for a double pipe heat exchanger. This double pipe heat exchanger consists of two concentric pipe, one inside the other. Generally, this inner pipe carries hot fluid and this outer pipe carries cold fluid. So, this double pipe heat exchanger are used to transfer heat between two fluids, that is hot and cold fluid, okay, without mixing the two fluids. Okay. This double pipe heat exchangers are used for heating or cooling of fluids, and then it can operate in two modes. One is co-current and another one is counter-current mode. Okay, so if both the fluid flows in the same direction means then it is known as co-current mode, and if the fluid flows in the opposite direction, your hot and cold fluid, then it is known as counter-current mode. Then the temperature difference between these hot and cold fluid creates a driving force for the heat transfer. Then the heat flows from the hot fluid to cold fluid through the wall of the inner pipe by conduction. Then the fluids also circulate within the respective pipe by convection. So the principle of double pipe heat exchanger is, it is based on both conduction and convection. So conduction is nothing but the heat transfer through a solid material, and convection is a process where heat transfer takes place by the movement of a fluid. Okay, I'm going to calculate the logarithmic mean temperature difference, because here the driving force for heat transfer varies from point to point on your double pipe heat exchanger. Okay. Problem is fermentation medium is cooled from 121 degree centigrade to 30 degree centigrade. That is, here we are going to cool the hot fluid, that is fermentation medium, from 121 degree centigrade to 30 degree centigrade. This is your flow diagram for the double pipe heat exchanger. So here your fermentation medium, that is your hot fluid, its temperature at inlet is 121 degree centigrade and at outlet it was 30 degree centigrade. So it flows in this direction. Okay. If cold water is flowing in the counter current direction and is heated from 10 degree centigrade to 70 degree centigrade. So your cooling fluid temperature at the inlet is 10 degree centigrade, but outlet your cooling fluid's temperature is 70 degree centigrade. Then formula to calculate LMTD, del T is equal to del T2 minus del T1 divided by ln of del T2 divided by del T1. Okay, here subscription 1 and 2. Okay, subscription 1 and 2 denotes the end of the equipment. So here del T1 and del T2 is the temperature difference between the hot and cold fluids at the end of the equipment. Okay, so this is one end of the equipment and this is another end of the equipment. Okay, so del T1 is nothing but that is TH0 minus TCI, temperature difference between the hot and cold fluid at one end of the equipment. So this is del T1 is equal to TH0 minus TCI is equal to, so 30 degree centigrade minus 10 degree centigrade is equal to 20 degree centigrade. Next del T2, so this is the another end of the equipment. Here you have to calculate the temperature difference between the hot fluid and cold fluid. So THI minus TC0. So 121 degree centigrade minus 70 degree centigrade gives 51 degree centigrade. So just substitute these data in this equation, you will get the LMTD. Okay, so first step you have to calculate the temperature difference between the hot and cold fluid at the two ends of the equipment. So this is one end del T1 and this is del T2. So del T2 is 51 degree centigrade. So 51 minus del T1 20 divided by ln of del T2 divided by del T1, that is 51 divided by 20 is equal to 51 minus 20 is equal to 31 divided by ln of 51 divided by 20 ln of 2.55, that is equal to 31 divided by ln of 3.55 is equal to 0.9361. So 31 divided by 0.9361 is equal to del T, that is 33.12 degrees centigrade. So your LMTD is equal to 33.12 degree centigrade.